Good afternoon. As Kelsey said, I'm a hydrologist with the U.S. Office of Surface Mining. I'm based out of the Pittsburgh office, which is the headquarter office for the Appalachian region, which basically they oversee. They're the regulatory authority for all the Appalachian coal states. So anywhere from down towards Georgia and Alabama, all the way up through Pennsylvania and Ohio is really your Appalachian coal region. And that office kind of oversees all the coal mining in that region. So I'm a hydrologist there. I've been there just over a year and a half, but have quite a bit of experience and background, as Kelsey says, doing mine water treatment. So that's really what I've been asked to talk to you about and delve into a little bit of both the engineering and chemistry, because without a doubt, as I've learned, you can't do one without the other in regards to mine water treatment. You really got to know chemistry in order to adequately do the engineering that's required for this type of water problem. First, I thought it'd be good to explain my professional background so you kind of see where I started from, which obviously was not an environmental engineer, and how I kind of got to where I am today through different schooling and through my work experience. I started off getting a Bachelor's of Science in Marine Biology from Millersville. Obviously it didn't take long for me to realize the job market was not that great, and kind of did my own thing. I did environmental lab work. As you see there, my first employment doing wet chemistry, microbiological tests, biotoxicity, which is where you're looking at the toxicity of a wastewater and seeing if it kills organisms. I did that for several years. And while I was doing that, I put myself through Masters of Environmental Pollution Control program, which is basically an environmental engineering program through Penn State. They have their Harrisburg campus, which is right near where I live. So I put myself through that and eventually got the master's degree. And through that master's degree, I think it's important to note, is where I became exposed to acid mine drainage or mine water through some of the classes I had. So that's really where my interest started in the world of acid mine drainage. However, work-related, I didn't actually do any work related to mine water treatment or acid mine drainage for probably another 6 years after that. So it kind of was an evolving thing, and I really wanted to get into it, and I eventually did. So once I got my master's, then shortly after, I ended up getting a job doing environmental consulting. First, I was doing lake and reservoir water quality work. So I was basically going to reservoirs, and we'd go out in a boat and measure the water quality. And I don't know if you know much about lakes, but they basically, sometimes they'll stratify. You get an anoxic zone at the bottom. You get the upper part that has plenty of oxygen, but the chemistry is so variable. And a lot of times we had to look at actually ways to how to improve that and keep that bottom from getting anoxic. So certain places they were required to try to do that, and that was something I did actually for several years before I worked at a company called Skelling Lloyd, which is where I got into doing mine water treatment and acid mine drainage. And that's really where that kicked off in about 2004. I started doing that work, and I had a lot of exposure to doing treatment design, really learning about acid mine drainage, understanding the chemistry, going and learning existing systems that were out there, and then basically evolving and learning how to do the engineering design. I really was trial by fire. I didn't have a lot of mentoring. I kind of had to learn it on my own, and it was challenging, but I learned a lot of lessons through problems that arose, and you kind of learn from your mistakes. I mean, what we did in one treatment system didn't work. Well, now you know for the future how to build upon that and do things better. So without a doubt, I mean, it's been a learning experience, and I still learn to this day. I mean, the field of mine water treatment is always evolving. It's never stagnant, so it's always changing, and new technologies and so forth. So, and then now, about a year and a half, I've been with the Office of Surface Mining. Basically, our group that I work for is really almost like a consulting firm to the Appalachian region states. Most of the states in the Appalachian region actually regulate coal directly. Office of Surface Mining is just kind of an oversight agency. The only state in the Appalachian region that we actually regulate the coal mining industry directly is the state of Tennessee. All the other states, Pennsylvania included, West Virginia, Maryland, Ohio, they all do their own regulating of the coal mining industry. But we kind of do an oversight. And my group specifically, if a state has an issue, they are having problems, say with mine water treatment at a site or whatever, a lot of times, I get called out to do work like that now. So it's quite interesting. I really based on my background of doing the mine water treatment design, I'm able to do a lot of the work I do today. So diving right into mine water treatment, why do we do it? What has really got us to this point? Obviously, there's been a lot of coal mining, and I'm going to focus a lot more on the state of Pennsylvania because that's where a lot of my experience is. I've dealt a lot in some of the other Appalachian states, but you'll notice a lot of my slides and information are really close to home here. It's Pennsylvania. This is where I'm born and raised, so that's where I'm going to focus on. But for those of you that don't know really what mine water is or what causes it, basically it's where the mining operations have exposed pyrite to air and water. That can be underground, that can be, which you got a picture of an underground mine here, a tunnel opening, or surface mines. So you got a mine here where they're strictly getting the coal out, extracting the coal out of the earth from the surface. They're not digging tunnels or any such features. So both of those are the common ways to mine coal. And you get those three things, the pyrite, the air, and the water, and you get mine water, which tends to be, depending on what it is, can be net acidic or net alkaline. And that really can be based on the type of mining, whether it's surface or underground. Those two can really dictate the type of water quality that you're going to have resulting in your mine water, if indeed there is a mine water discharge. Not all mines, once they're done, create a mine water discharge. But from prior to there being regulation for coal mining, a lot back in the day, say back in the 1960s, if a coal mining company didn't want to extract any more coal, they could just walk away from the mine and they're done. The water pollution problem then that resulted, or if there wasn't one that resulted, there was nobody left to help to deal with it. It was just, water just went with streams and killed the streams, and that's just the way it's been for years until they passed regulations back in the late 70s. And I'll delve into that here in a few moments. So basically the premise and what a lot of my background was in watershed and stream restoration. Which is why there's been a lot of money put into the idea of trying to restore the streams from all of that past mining that was conducted before there was laws in place to hold coal companies responsible if mine water discharges occurred at their site. And what the main regulatory act that came into effect, which you see right here, I call SMACRA. SMACRA stands for Surface Mining Control and Reclamation Act that was created in 1977. That act actually formed the agency that I work for today, the Office of Surface Mining. And once that came into effect, you now have what are classified as Title V sites, which are sites that are active, meaning there's an active entity, there's a coal operator there that is responsible for the site should a water discharge occur. And they're held to standards. They have to treat to meet permit limits, etc. And they're responsible for that water in perpetuity until it's either they're no longer in business or until the water no longer is a problem. Then you have Title IV, which actually that's more of what I historically have been involved in before I came into this position. Title IV refers to those sites where the mining was done before 1977 when SMACRA came in, and all those companies that just mined the coal and walked away, they're done. They're not responsible. There's nobody on the hook to treat that water anymore. And so what ends up happening, who's going to pay to treat that water now? You have water coming out of an abandoned mine site, which are called AMLs. Abandoned mine land is a common name that you'll see referred to on sites that have no responsible party to deal with the problems. Now, whether that's reclaiming the site, whether it's just an open pit, or a high wall, or whatever that was just left there, which those things tend to create safety hazards. Those are a little bit different. I'm more focused on the water part of things, if a water discharge is created. So, you know, that's kind of what that's referring to with the Title IV thing. But there's lots of money out there that is available for states to help address these Title IV AML water pollution issues. The state of Pennsylvania is probably one of the, I'd say, most effective in how they've used this money and put it in place to get water treatment in place for all these Title V AML sites. And I'll get a little bit further into that, how they're able to give money to people to try to deal with the problem. But the main premise, again, is trying to fix streams and rivers in the Appalachian region from all the decades of illegal mining that occurred, where there's nobody responsible to deal with it. And here's just a picture of a nice orange stream that most people think of when they think of coal mine water or acid mine drainage. The extent of the problem, basically the most acid mine drainage or mine water is the most extensive water pollution problem affecting the 4 main river basins in the state of Pennsylvania. It impacts over 5,000 miles of streams in the state of Pennsylvania. It is a huge pollution problem. Now, granted, you know, every year there's leeway being made, and streams are being improved, and some even periodically are being taken off of impaired lists, that they're able to actually sustain aquatic life. So things are moving forward. It just takes time and money. And because the coal mine drainage can contain toxic concentrations of metals and acidity and other things, many of the streams that are impacted by it have no fish or aquatic life for that matter. It's pretty detrimental if you've ever seen a stream that is impacted by mine drainage. It's pretty catastrophic. Consequently, the state of Pennsylvania actually loses millions of dollars every year because they don't have the resources for sport fishing that they would get financially from people coming into the state to fish in these streams, because they're dead. They're dead. I mean, there's nothing that can live in the streams because of the toxicity of the mine drainage. And probably about 10 to 15 years ago, it was estimated that it would cost about $5 to $15 billion to restore or deal with all the water pollution problems caused in the state by mine discharges. That's a pretty phenomenal dollar figure to think about. It's kind of a blurry slide, but it gives you the idea, for those of you that aren't familiar with the coal regions of Pennsylvania. This huge orangish colored one is the bituminous coal field, which essentially we're in right here. Is massive. I mean, it takes up a major part of the western part of Pennsylvania. And obviously that's where a majority of the mine drainage problems are, in the bituminous region. And then you have these small little isolated pink regions that are the anthracite fields. And for those of you who don't know, bituminous means soft, or a soft coal. Anthracite means hard coal. So those are the real differences. And it actually does end up resulting in usually different kind of water pollution problems from the different coal fields. Just as a note, a lot of my background, actually, I did a lot of work right here in this little isolated field, which is in the northeastern part of Bedford and southwestern part of Huntington County. So I actually did and that's a unique little area there. It's called the Broad Top Coal Field. It actually isn't a true bituminous. It's actually, some will call it a hybrid of these two coal fields. So but it is, in this part, it's classified as a bituminous, but there's some unique water quality issues there as well. This one again is a little blurry, I apologize, but it gives you an idea of the extent of impaired streams in the state of Pennsylvania. All these red areas are impaired streams from mine drainage. And you can see how much of that area that was bituminous is impacted. And then you see these little isolated areas over here in the eastern part, where the anthracite fields were, that are all impacted by mine drainage. So it's a pretty extensive problem, and things are getting better. here's a good picture. It's amazing where you can see these things. I mean, here's a, just an example of a trail. I mean, here's a walking trail. And here you have this huge abandoned mine discharge. Nobody's responsible for it. It's just spewing out toxic metals and low pH water right here and just going into a stream that's not being dealt with. And it's just amazing. I've seen so many things like this. It's unbelievable. It's hard to believe in today's age that this still happens. But it takes a lot of money, and unfortunately, there's not the money there to deal with it all at one time. Okay, first you got to delve into the chemistry, like I said, how important understanding the chemistry is when you're looking at mine water treatment and what you got to do to fix this water. And I don't know how many here are big chemistry fans. I know, I kind of was forced to learn it quite a bit through schooling, but then through work I actually became more interested in it just because I realized how important it played in understanding mine water treatment. But this is just a graphical example of a field titration that was done on a mine discharge. What we were trying to do was just understand acidity. Acidity is the main thing you're looking at dealing with typically in mine water. What we're trying to do is acidity is really, it tells you how much alkaline material must you add to the water to increase the pH, which we're trying to go to the right here, and get these metals out. This water specifically had aluminum, ferrous iron, manganese, and magnesium.